Okay, this is the warm-up for 9-7. Copy all of this work. Hopefully you have a piece of graph paper. Copy the 5 words to show me that you listen. Please do not share these words with anybody. All right, so again, write down these numbers. You need to know there's 2 kinds of sequences: adding, subtracting, arithmetic, timesing, division, geometric. This first one here, again, I'm looking at the difference between -54 down to -37, down to -20. The only thing that makes numbers do that is adding a number positive to that -54. So for my advice for this problem, which is specific, take that 54, take that 37, just take plain number without any minuses on them, subtract it, see what that difference is, because that difference is the number that you're going to be adding each time. So for this one, it's arithmetic, adding 17 each time. Recognize this one. You will see one similar to it. Adding 17, adding 17. First word is cat. Cat. Adding 17. That makes this arithmetic, makes this a straight line. If you were to graph it, arithmetic, knowing that if I'm adding 17, keep going. -20 on my calculator plus 17 positive gives me -3. I'd like you to find the next couple values. And then keep going. -3 plus 17, don't clear your calculator, gives you 14. Be able to go backwards. If I'm adding 17 to the right, I'm taking away 17 going to the left. Let's erase this so we're not confused. So again, -54 on my calculator, subtract another 17, -17 gives me a bunch of negatives, -71. And then if I keep going, -71 minus 17 gives me -88. So again, adding 17 to the right, subtracting 17 to the left. Know this problem. Next one is not going to be arithmetic. It's going to be geometric. I know that because if I add this chunk, it's going up or down by 6. This is going down by 3. As soon as you see anything different, going at a different change of rate, that's a geometric. That's going to be one of these curved graphs, exponential. So again, to get it, take this 6 and divide it by this 12 right here. See what you get. Looks like I'm dividing by 2. Dividing by 2. 6 divided by 2 gives me 3. But remember, the way we show it, the next word is goat. Goat is the second word. The way we show it is not dividing by 2. We show that as timesing by the reciprocal of 2. So if I take 2 and flip it, it becomes 1/2. Dividing by 2 is the exact same as timesing by 1/2. If I take 12 and I divide it by 2, that gives me 6. That is the same math as taking 12 times the reciprocal of 2, which is 1/2, and then just timesing straight across gives me 12 over 2, or another way of getting that 6. So remember, dividing by 2 is the same as timesing by the reciprocal of 2. So timesing by 1/2. So if I was to keep going, taking that 3 times 1/2, multiplying straight across, gives me 3 over 2. If I take that 3 over 2 times another 1/2, remember numbers on top stay the same, gives me 3 over 4. Next one would be 3 over 8. Notice that 3 number is not changing, the bottom number is. Going to the left, though, is the opposite. The opposite of timesing by 1/2 is timesing by the reciprocal, timesing by 2, or 2 over 1. Timesing by the reciprocal, or 2, plain old 2. So again, take that 12 times 2, 24. Take that 24 times 2, gives me my next term, 48. So be familiar with these specific sequences, a geometric and a arithmetic. Know how to get these numbers. All right, today, what we're really going to do is focus on taking a sequence and numbering them, having this be the first term, having this be the second term, having this be the third term. Make sure you write that, because when you write it like that, it gives you coordinates where these are the y coordinates, these are the x coordinates. If I was to make like a little table, if you want to make a table, but again, those are coordinates. That first coordinate, the first term is 1, 3, or when x is 1, y is 3. Second term, when x is 2, y is 5. Again, we're numbering the terms. When x is 3, y is 7. If we were to plot those, which I'd like you to be able to do, on a graph, over 1, up 3, over 2, up 5, over 3, up 7. Know that this gives me a straight line. And know that on this graph, you got certain numbers here. You have the 0 term, or when you go back a sequence here, because again, for this, looks like I'm adding by 2, subtracting by 2 to the left gives me the 0 term, 0, 1. That's here, right here. There's the y-intercept. That's the 0 term. If I keep adding by 2, that is my slope. Over 1 up 2, that's my slope. If I was to keep adding a 2, I'll get the next number in my sequence, the fourth term, which is 9. Or if I look at my graph, from this point over 1 up 2, gives me that point right there, 4, 9. So make sure you write all of this. Numbering a sequence, making it into graphable form. Next word is dog. Dog. Last problem for the warm-up. I need you to know this is going to get weird. Here we go. First term, 1, 2, 3. We want you to know to find this fourth term right here. I don't need any math. All I need to know is how much I'm adding each time. Adding 3, adding 3. All I got to do is take this 8 and add 3 to get 11. No math really needed there. But what we're going to do to make this hard, of course, we're going to look at what's called the recursive formula, which is this. You could find any term in the sequence by using the 1 before it, adding the common difference number, which is that 3. So the recursive formula for this sequence is I could find any term by using the 1 before it and add 3 each time. To show you how this works, that fourth term already we know is 11 because you're smart. To find that fourth term using this weird function notation, next word is pelican. Pelican. We're going to show it like this. I'm going to show you today, I promise. To find that fourth term, which we know is 11, again, to find the fourth term, f of 4, we plug in 4 right here. We have that plus 3 already there. That gives me the fourth term, which we know is 11, is found from the third term plus 3. At this point, we pop this F3 out of here with what it really is. The third term is 8. So I pop that F3 out of there and I put the actual numeric term, the third term in the sequence, is really the number 8. And then that plus 3 gives me the fourth term, which we already know is 11. We're going to be looking at weird function notation, recursive formula, common difference, slope. All right, last word is fish. Fish. Good luck. A little glimpse of what we're doing today.